When we discussed hydrocarbons, we talked about how we can name hydrocarbons based on size, as well as shape. Although we discussed the specifics of naming hydrocarbons due to shape in a later video, we need to discuss the concept of shape itself. When we form hydrocarbons, we often see branches in a chain. We need a way to describe the shape of certain carbon atoms. For instance, how do we describe the differences between carbon atoms in this molecule? Let's discuss the differences between carbon atom all the way on the left, the carbon atoms second and third from the left, and the carbon atom second from the right. The carbon atom all the way on the left is only attached to one other carbon. We call this kind of carbon a primary carbon. The second carbon is attached to two other carbons. We call this carbon a secondary carbon. The third carbon is attached to three other carbons. We call this carbon a tertiary carbon. The fourth carbon is attached to four other carbons. We call this carbon a quaternary carbon. We don't have to write out the entire word every time. We can show primary, secondary, tertiary, quaternary as its corresponding number and a degree symbol. As you can see, we can use this system to specify the branching of carbon atoms. To practice, pause the video and label the remaining carbon atoms. Here are the remaining carbons labeled. This system isn't only used for hydrocarbons. We can also use this system to describe alcohols and amines. When we talk about alcohols, we specify the attachment of the hydroxyl group. We designate primary to alcohols when the carbon bearing the hydroxyl group is attached to only one other carbon. Secondary when the carbon bearing the hydroxyl group is attached to two other carbons. And tertiary when the carbon bearing the hydroxyl group is attached to three other carbons. A quaternary alcohol is impossible since the carbon would have 5 bonds. For amines, this system changes slightly. When naming amines, we no longer focus on what is attached to carbon atoms. Instead, we focus on the nitrogen itself. If nitrogen has 2 hydrogens and is attached to one carbon chain, it's primary. If nitrogen has 1 hydrogen and is attached to 2 carbon chains, it is secondary. If nitrogen has 0 hydrogens and is attached to 3 carbon chains, it is tertiary. I like looking at the hydrogens when determining this for a reason. A cyclic amine is secondary, even though it is part of 1 carbon chain. An amine that is part of an aromatic ring is actually tertiary, even though it is only connected to 2 different carbons. I like remembering that the classification of an amine is 3 minus the number of hydrogens. 2 hydrogens makes it primary, 1 hydrogen makes it secondary, no hydrogens makes it tertiary. This concludes our discussion of classification of functional groups, and actually concludes the topic of functional groups. The remaining videos of this chapter will focus on the basic properties that will come up during the entirety of this course.